Well, in this video, we are going to take a look at a couple examples of using integration by parts. And the first example is taking a look at the integral of x e to the x dx. So we have, from the last video, our integration by parts formula is the integral of u dv is equal to ub minus v du. So we want to identify a function to be u and something to be dv. We have the mnemonic ILATE to pick out our u and dv, or specifically to pick out the u. I stands for inverse trig. There is no inverse trig here. L stands for logarithmic. There is no logarithmic. A stands for algebraic. We have just this x by itself, so that is what we're going to pick to be u. What we pick to be dv is everything else, including the dx. So e to the x dx. We take the derivative of u, and we integrate dv, getting du is equal to dx, and the integral of e to the x is e to the x. So filling in our formula, the integral of x e to the x dx is equal to u times v x e to the x minus the integral of e to the x dx. Now we can integrate e to the x dx. We already have the integral of e to the x is e to the x plus c. So the antiderivative of x e to the x is x e to the x minus e to the x plus c. Taking a look at a second example, suppose we want to find the integral of t squared sine 2t. Using our integration by parts formula, we need to identify a u, a dv. Once again, we don't have any inverse trig. We don't have any logarithmic. We do have this trig of a t squared. So that will be our u, making our dv, everything else, including the dt. Take the derivative of u, so du equals 2t dt. Take the integral of v, and the integral of v is negative 1/2 cosine 2t. Filling in our formula, the integral of t squared sine 2t dt is equal to u times v, t squared times negative 1/2 cosine 2t, so negative t squared over 2 cosine 2t, minus the integral of negative 2t over 2 cosine 2t dt. Simplifying that integral, we have minus a negative would be plus the integral. 2 over 2 is 1, t cosine 2t dt. This piece requires integration by parts again. So we can use integration by parts multiple times. Using integration by parts again, we'll identify u, this time to be t. So du equals dt. and dv equals everything else, cosine 2t dt, making b the integral, which is 1/2 sine 2t. Copying the parts we already have, we already know t squared sine 2t dt is equal to negative t squared over 2 cosine 2t minus. Now here's the thing that we have to take the integration by parts on again. So filling in the integration by parts again for that blocked off piece, we'll have u times v, which is t over 2 sine 2t minus the integral of 1/2 sine 2t dt. We can integrate 1/2 sine 2t dt. That is copying everything down first. The integral of sine is negative cosine. Negative of a negative cosine would be a positive 1/4 from 1/2 times 1/2 cosine 2t plus c. And I copied this row first, ignoring the fact that this had actually changed to a plus. So using that sign from our negative times negative, we get plus all the way across, getting our integral of t squared sine 2t dt of negative t squared over 2 cosine 2t plus t over 2 sine 2t plus 1/4 cosine 2t plus c.